Bismillahirrahmanirrahim. Welcome back in the second class. A bit late because I was setting up the system. Yesterday we discussed about sequencing technologies and a bit of molecular biology, and where we have gone, what we have progressed. We discussed about Sanger sequencing, next generation sequencing, and some real time sequencing methods, long read sequencing methods, single molecule real time sequencing like PacBio and Nanopore. So, uh, as I discussed today, most of today is hands-on. We will discuss some command line options, uh, books for the recommended for this course, as some of the students have compulsory. This course is compulsory for them, so I will suggest next generation sequencing and DNA and data analysis. I will share that book for the first lecture, and for the second one, the Unix workbench. This book, Unix workbench, is based on a course on Coursera. So you people would have higher education commission access of Coursera, so you people can do that course as well. So that course and this book are almost same. Okay, so why we are using Linux command line, and what are different options to interact with the operating system? Because our computer has an operating system, and we have to perform everything on that operating system. So we have two options to interact with the operating system. One is a graphical user interface. So in case of graphical user interface, as you people can see, that we have like Mega, we have point and click system. We have something written, and we can click on that, and function is performed. The second option is a command line interface, in which it's a black box. Nothing is shown on the black box. And what we have to do is we have to write some commands, and according to the instructions in that command, a function is performed. Uh, there are two basically options in bioinformatics. You can have web-based softwares or graphical user interface, and you have a command line interface as well. So when we talk about web-based applications, we have NCBI, we have EBI, DDPK, we have Biomart, we have Galaxy, where you can access many of the programs. And when we talk about command line, we have Linux, we have R, we have Python, and many of the next generation sequencing analysis tools are based on the Linux. Uh, there are different reasons we are using Linux system, and you will get an idea after we complete this lecture. First one is the time. Second one is we perform repetitive tasks, and to perform repetitive tasks, you have to click again and again and again. But in Linux, you can give a command, and you can go for the coffee, and the system will be working for you. This is the power of Linux. In addition to that, we have in bioinformatics and computational genomics, we have hundreds of GBs of data, and the notepad of the Linux has the upper limit of 58 MB. If your file is more than 58 MB, it will not open it. And you can imagine that human genome is 3.2 GB. How will it handle? Similarly, if your Word file is around 500 MB, your system will stuck. It will not work opening that Word file. So in Linux system, you can handle hundreds of GBs of data. What is basically Linux? It's an operating system, and there are different flavors of this operating system. There are Fedora, Debian-based systems, Ubuntu. Most of the people prefer Ubuntu for bioinformatics tasks. So some are commercially distributed, some are community driven. They are made by community for the community, and they are freely available, like Debian based systems. Ubuntu is based on Debian, so it's also free. So when we talk about Ubuntu, the power of Ubuntu, our Linux operating system, is in the shells that we also call it terminal. So the power is in terminal. There are different shells in in the Debian system, in the Linux system. For example, Bash, CSH, ZSH. There are other shells as well. Uh, but the most common is one is bash. I will show what bash is. So if you have installed Linux subsystem, if you some of you are successful in installing Linux subsystem, have you done that? Some of you may have encountered some problems. We can discuss after that class if someone encountered a problem. But if you encountered a problem, there is another option of installing a Linux subsystem, and that is through PowerShell, Windows own PowerShell. You can see many tutorials on internet as well. So that should be easy. But if you have problem, we can discuss after the class. So when we open a bone again shell, that is a bash, so there will be a black box, and in black box it will be name of your username that you decided on first on installing your bash, and then name of your system and the location where you are. this small this small symbol is known as tilde, and this denotes your home directory. I will discuss what is home directory. And until you get that sign, that dollar sign, you cannot run a command. So if you run a command and this is running, this will not appear. Until this appears, you cannot run another command. So uh, there is a home directory and there is a root. I will show what a root is and what is home. So as I said, this sign, this denotes your location. So I change the location to root, and you can see that a symbol, a different symbol appear, forward a sign appears. So this denotes a root location. What is root and what are the file systems? So in Windows, when you open File Explorer, you go to a window where you have three options: uh, drive C, drive D, and drive E, or whatever you have named it, right? So when you click on the File Explorer, it goes there, and you know where you are, and you also know what are the options where you can go from there. You can double click on the D drive and you will enter in that D drive. You can double click on the E drive and you can enter into the E drive. So Windows has a system where there is a drive, and that drive have different folders and files. You can enter into the C drive and you can see different folders and files, and you can also double click on these folders and get entered into that folder. So Linux is slightly different. Most of the hierarchy is same. So there is something known as root. On that root, everything is on that root. You can see this is the root, and there will be many folders in that root. Most of these folders are actually system information, uh, some applications, some commands, some libraries. uh, you are sitting in the home or users, and in home you will have your own name that you have your username, and in your username you will have all of your data. So you are sitting on root. In root, there is a home directory or folder. So directory and folder are same thing. So in Linux system, we say directory. So in directory, there is another. There will be home in home directory. There will be another directory by your username, and in that username, all of your stuff will be present. So when you click on bash, you automatically goes to the home directory, your user directory. So you are in your user, and nothing will appear, just a black box. So you don't know what is in your your user directory. So I will show in a bit, but let me cover some of the material. Uh, there are some shortcuts. As I have already told, there is a tilde, and tilde means your user's home directory, and a single dot. Single dot means your current directory, and a double dot means parent directory. If you want to go to one step above where you are, you have to write double dot, cd double dot. I will discuss that as well. But double dot means parent directory, the directory where you are sitting in. So there are two different there are two different options to go from one place to another place. One is absolute path and second one is relative path. Uh, Absolute path is, for example, you want to go to documents. So your path is root, users, Lucy, and documents. This is your absolute path, because path starts from root, and in root there is a directory users, and there is another directory Lucy, and in that directory there is a directory documents. If you want to go to documents, the absolute path is that one. But there is a relative path as well. Just imagine, if you want to go to adjacent room, there are two options. One, you are coming from outside, and you will go to that from maybe from the gate of the University of Karachi. Uh, but if you are sitting here, you can use relative path, and relative path is the next room is just adjacent to this room. And if you don't know that path, you have to go to the if you only know the absolute path, you will have to go to the gate of the University of Karachi, and then you will go to the adjacent room. I will discuss a bit more about that concept as well. So the power of Linux and Bash is in its commands. So the structure of the command is, there will be a command, and there will be some options of that command, and a third will be arguments where you want to perform that command. Uh, for example, ls is the command. If you run ls, it will list all the folders and files present in that directory. But there is an option of -a that will list every folder, even if some folders are hidden in that directory. So option actually change the behavior of the command. Like if we use option A, it will list everything, even if some of the files are hidden in your directory. These will not be shown if you just write ls. So arguments means where, in which directory you want to list all the files. There are two different conventions for options. Options are also known as sweeps. So you can use a minus symbol, or a dash symbol, and then a single letter, or you can use a double dash and then the full name of the full name of the option. So there are two conventions. There are some manual PGs. For example, if there is a command, you don't know the usage of that command, you will write man, that is manual page, and then you need to write the name of the command. So in bash, there is a command line completion option. If the name of your folder is very long, you just can write tab. So you need to just press tab, and it will complete its full name. For example, if you want to write desktop, you just need to write DE and press tab. It will complete. That is known as tab completion. So some of the wildcards as well, I will discuss that. These are some of the demonstrations uh, where you are, when you just open a bash, it will be just a black box. Like, let me show that to you people. If we can open my bash. Um, so I am in my home directory. Currently, I'm in my home directory. But if I want to explicitly know where I am, just press print working directory, PWD. It's a shortcut for print working directory, and enter. So this is in root, there is a home, and in home, this is my username. What is in that directory? Let's see. So nothing is in that directory. I press ls, nothing is shown. Let's create a file. Um, File one dot txt. Touch will create an empty file. Let's now see what is in that directory. So there is a file one.txt that I just created. So what is actually happening, by print working directory, you can know the your actual path. By ls, you can know what is in the path. By knowing what is in the path, you will know the options where you can move. For example, let me go to one more thing that is slightly different from if you install a Linux subsystem in your Windows, and if you are using actual Ubuntu system, the difference is your subsystem is mounted on MNT, and on that MNT there are C, D, and E drives. Let's go to D drive. If you want to go to D drive, you will, if you are working in your home directory, it will be working in C drive, and you would not like to work in C drive in case of Windows. So move to the D drive where your Windows is not present. And to move into D drive, you have to type cd change directory. You want to change the directory, and you are providing absolute path, and the absolute path is, there is a root, and in that root there is a directory mnt, and in that directory there is a directory t. Press enter. Let's see what is in it. So I have a lot of stuff in D drive. I have made a folder iccbs. I see. I just write IC and I press tab. It will complete. That is tab completion. Enter. So I'm in ICCBS. If I want to know actually what is my working directory, print working directory. This is the actual path that I just discussed. What is in that directory? These are the files that are present in that directory. Okay. So if I want to create a file, I can use touch. If I want to make a folder, I will use mkdir, and name of the folder maybe second. Second named folder was not present. You can see that there is no folder named second, but if we ls again, it will appear. So there is a folder named second. So let's also use some options. ls will list every file and folder in your working directory. ls space dash a will show everything, even hidden files. There were no hidden file except two hidden files, and these two hidden files are present in every directory. That is dot and double dot. Dot means current directory, and double dot means previous directory in which ICCBS is present. Let's show that. So if I press cd space dot dot, I will go to D drive. So ICCBS is present in D drive. When I am present in ICCBS, if I type cd dot dot, I'm going into the parent directory, and parent directory is D drive, right? You people are following, right? All right. So there are some wildcards that I also want to discuss. No, root directory is the directory where everything is present. Current directory or working directory is the directory where you are currently present. For example, currently I am present in D drive. So I can root directory uh, in root directory there is a directory mnt, and in that directory there is a directory D, and I am currently present in D. So root is different and D is different, and you should not work in root directory. Never go to the root directory unless it is very necessary. Otherwise you will do something, being a beginner, you will do something that will raise your whole system, and there is no undo command in Linux. Once you erased something, there is no recycle bin. Everything is lost. So be very careful, especially when you are, even when you are expert, be careful, because and have backup of your very crucial data, because once it is raised, it is raised. There is no undo. Okay. So let me show some wildcards as well that I discussed in slides. Let's make some more files. Let me clear. I think font size is good enough. I increased the font size. I hope that font size is good enough. If you feel I can increase that font size, it's good enough, right? Okay. Yes, in case of Windows subsystem, you just you said how can we increase the font size? Just right click, go to the properties, and there are different options. So in font, you can increase the font size. By default, I think it's 16, and I upgraded it to 36. I don't know if there is any command. There should be some command, because whatever is happening, for example, if we are clicking somewhere, in the backend, there is some command that is running. There should be some command that will increase font size, but I don't know. I do this by this way if I have to. Okay. So uh, let's create, currently we have, let's go to ICCBS that have less stuff as compared to D drive. Clear. Okay, in ICCBS, I have these files. Let's create some more files. Touch, just ignore. So 10, I will generate 10 files with the extension tab. So I have some files with the extension tab and some files with the extension txt. So what are wildcards? There are two types of wildcards. One is star, and the second one is question mark. Star means anything. For example, I want to list uh, anything that ends with tab. So before dot tab, there can be anything. And if I press that, all the files that have a tab in their extension will appear, and none of the file that have extension as a txt, none of that will appear. So this is how we can use wildcards. So second wildcard is the question mark. Let's print all the files that have txt at the end, and the numbers are 1 to 9. Let's see what we got. So the files had file 1, file 2, file 3 to file 10. So question mark means 1. So at that position, there can be anything one times. Star means anything, any number of times. Question mark means anything one times. So when we said ls star dot tab, so star means anything, any number of times, and that is why file 1, file 2, file 3, file 4, file 10, everything got printed. When we said uh, file question mark dot txt, it means uh, in place of that question mark there will be one digit, and it can be anything, not only digit, it can be any character. So it printed file 1 to file 9, and no file 10 is printed. So you people are following. So these are basically uh, wildcards. One suggestion that I will make: what is the structure of the command? The structure of the command is command and option and then argument. Let's see. I want to see what is in snips. So snips folder has two things. What I write in that command, print everything in the snips folder, not in current folder. I was in ICCBS and I want to see what is in snips folder. So I don't need to go into the snips folder. I can provide the path of the snips folder. There is another option. We can go to the snips folder and we will say ls, and the same thing will appear, except I use two arguments that change the behavior. Uh, these three files are present: dot, double dot, and snips dot vcf. Uh, I can show these files by present in current directory or present in wherever I am present, but I have to provide the path where I want to see, where I want to peek. Okay, so a bit about relative path and absolute path. Let's see. I go to ICCBS by typing cd dot dot, and there are two folders, second and snips, right? Second and snips. If I go to second, I'm currently in second. If I want to go to snips, there are two options. First is absolute path, and second one is relative path. Once I will first I will talk about absolute path. The absolute path is there is a root directory. In that root directory, there is mnt and then d and then ICCBS. And in that ICCBS, there is a folder snips. I press S and then tab, it will not complete because there are two folders starting with the S. And if I press double tab, it will show that there are two options where you want to go. I will say N and press tab, it will complete because there is no ambiguity. No, you are following? Okay. So this is the absolute path. If I press enter, currently I am in snips folder. Where I was previously, I was present in second folder, and I use absolute path to go into snips folder. So what is a relative path? If I want to go back to the second folder, folder named second, actually, there are two options. First, we can use absolute path. It will just same as I went from second folder to snips folder. Uh, and there is a the second option is a relative path. Relative path is because we know that currently we are in snips, and the second folder, the folder named second, is present in ICCBS. That is the parent for directory. Just go back to the parent directory and second. So this is relative path. What is relative path? CD, go back, and then from back go to the second folder. No, we are in second folder. Any ambiguity in the relative and absolute path, because this is a crucial some of the crucial commands. So good. Relative path, absolute path is starts from the root. Relative path is relative to where you are currently present. Um, uh, this is how it works. A suggestion that I want to make: when you are dealing with the bioinformatics data and genomic data and working on the command line, never use the spaces in your file names or folder names, because what will happen actually, let me show. Let's make a folder mkdir Ali Raza. I used space and I want to create a folder named Ali Raza. What it will do? It will make two folders. One Ali, second Raza. What is actually happening? Uh, Options and arguments are separated from commands using spaces. So spaces are considered as separators between options and commands and arguments. And the system does not know that I want to make a folder named Ali Raza with a space. If we explicitly want to do that, we can do that, but don't do that. If you want to name a folder Ali Raza, you can do Ali underscore Raza, so that whole name is continuous. It will make one folder. Although there is an option mkdir, use inverted comma Raza Ali, sorry, space. So in that case, it will consider it as a whole string, and it will make a folder with the space. It can make that, but in many of the cases, it will disrupt your script. So it's not a good point to use spaces in your files and in your folder names. So never use that. If you want to delete some file, let's create a file.txt. This is present. If you want to remove that, rm for remove file, name of the file, and then list everything. There will be no file named file.txt, because you just removed that. You first created and then you just removed. Okay, if you want to delete a folder, use rmdir and Ali. It will delete Ali. Uh, we clear that and go to the top and ls. You can see there is no folder named Ali. But if it is it has something in that folder, if it is not empty, rmdir will not work. You have to do rm space .r is an option that says remove it recursively, even if it is not empty. So be very careful with the rm command. We have we are short of time. Let's go to back to our slides. Sorry. Uh-huh. These folders are present in Windows system. Let me show that. These are not backend. They are actually physically present in your system. File Explorer. Let's go to D. and there are many things. One folder is named as ICCBS, and second was not actually present. I just created by MTDI, right? So it has been created and it is physically present. And files.txt were present before. Files.tab were not present. I created in front of you, and these are physically present. And in second, these are the folders I just created, and these are physically present. And if there is something you physically create at that location, it will be shown in your bash as well. So they are not disconnected. Bash has full access to your system, and if you do something in your system, it will be accessed by bash, and if you do something in your bash, it will be accessed by your system. Everything is happening in your physical RAM and hard. Nothing is hidden. Everything is present in your system, right? Okay. So back to slides. Yes.
Why we are using Ubuntu? Can just simply delete the file after Windows.
So there are multiple reasons why we are using Ubuntu. For example, if we want to create 1,000 files, what you will do, you will right click and create a file named file1, and then again right click and create a file. And if you are if you want to create 1,000 files, you will create 100 files, and you will be tired. There are many repetitive tasks that you want to do programmatically by using some commands. If you want to create 1,000 files, this is as simple as I show you. Uh, so let me go to MNTT and ICC APC 1 2000 in second. Okay, you want there are this is just an example. You want to do you want to take an input and get you want to get a result, and you want to feed that result into another program, and the result of that program you want to feed into another program. So you want to use a complete pipeline, and that thing you can do in Linux, but in Windows, in graphical user interface, you will click on that, you will wait for the result, and then you will click on the second command, and then wait for the result. Using Linux, you can have a script that have hundreds of commands and documents and scripts that are running one by one. After one is completed, and you can go to the coffee, you can go to the lunch, and system is working. There are instances where I run something on my system, and I put that system anywhere, and I just go to home. When I come back, it is completed. So this is not possible in Windows system. So there are some good reasons. That is why most of the bioinformatics tools and softwares are on Linux-based system, and uh, and there are memory issues as well that I just talked about. Yes. Yes, we can do many things. We can do this was just an example for demonstration purpose. There are different uh, options that you can do. uh, so in programming, you can do actually anything. That's not a problem. Okay, so let's go back to our slides. So these are some wildcards that I have discussed. So this is just moving around. I have demonstrated that. I have demonstrated mkdir. It creates a directory. Then remove. How can I remove a file? How can we remove a directory? Yes, one more thing, that is, if we want to copy a file or move a file. Let's go back and have a demonstration. Okay, so I'm in second, and let's see, second has I create a file named test file, test.txt, and that file is not present in snips. Let's check. There is no file named test.txt, but test.txt is present in second folder named second, right? If I want to copy test.txt to snips folder, I will use cp name of the file and location where I want to go. So I will use relative path where I want to copy that file. I want to copy test.txt that is present in second file, second folder, and I want to copy that into snips that is present in parent directory. And let's check if that has been copied. Go to snips and ls. It is present in snips as well, right? And if you want to move a file from one place to another place, just write mv. Let's move that test.txt to iccbs, and to move it to iccbs, I will go in the parent directory, because I am currently in the snips and I want to copy into iccbs, that is the parent folder of snips. Just say dot dot and see if it is present. I have created a lot of files, but test.txt is present in iccbs, right? So this is how we can copy a file, move a file. Yes.
Softwares like SPSS and MATLAB, when we try to copy it to another folder because of the file size, it takes too much time. But if we try to do it in a minute, we just need to write this command and it will do it in a second.
I think there may be a bit of difference, but the difference is not too much. These files are actually empty files, so they are just promptly being copied and pasted. It will take if files are heavy, but which one is faster? It may depend on your hardware. It may also depend on softwares as well. But I don't think it is specifically dependent on command line user interface and command line interface or graphical user interface. It depends on your RAM and your hardware. These are the things that are actually. Uh, so let's go back to slides as well, see what we have. So, so cat, less, head, and tail. If we have different files and we want to see that file, if we want to view that file, we will use. There are four commands, commonly used commands: cat, less, head, and tail. By using cat, you print all the file, and most of the time you are not using cat, because some of the times you have GPs of information into your file, and cat will print and print and print and print and keep on printing your file, because your file is very huge. If the file is small, yes, you can get that file. If the file is very large, what you should do is less. Less will show one page at a time, and you can scroll down and see the whole file. Head will print top of the file. By default, it prints 10 lines from the top, and tail will print 10 lines from the end. So you can peek into the top of the file and end of the file, and you can have an idea what the file is about. So a bit of demonstration. In let me see, let me clear that and go to Snips. This is a VCF file. If I look at it, it will print everything. So this is not useful. If it is some command standing, you see to cancel that. What you want to add the nibs and will print the top of the top. You can use an option of n and say you want to see lines, 50 lines will be printed, right? So if you see tail file, so tail file will print 50 lines. Okay. So if you want to paste two files, you can use paste command. If you want to find some unique values in a file, there is a command called unique. If you want to find a pattern in a file, that is grep, and if you want to remove some lines from a file, there is set, and awk is also a big program for file manipulation. I think today we are short of time. Just have some demonstration on these commands, and we will discuss rest of the lecture tomorrow. So let's see WC of the NAPS file. It will show three things: lines in that file, uh, characters in that file, and words in that file. The first one is lines in that file, second one is words in that file, and third one is characters in that file, and next is the name of the file. So if you want to see the number of lines in a file, print WC, and if you are only interested in lines, print C with an option -L and snips. This will print just the lines. If you are interested in just characters, right? Next commands are, let's see. I want to see first column. column from F option, and you need to say which column and then name of the file. It will print first column, but it will print everything. I just want to see first 100 lines. So this is the first column. So SNPs file, VCF file is basically based on SNP. So it shows that in chromosome A1, which was in that I used another command, another thing that is pipe operator. Means you want to cut means you want to extract just a first column and then you pipe it tomorrow. But because I have used it means output the results of cut command as an input to the head command, and you can see that when I'm using head, I am not using any file name because it is taking the output of the cut command as an input to the head, right? So this is pipe. You can pipe the output of one command to the as an input to the next command. So next is grep. If you want to see just chromosome CHR1B, you can see write grep CHR1B and name of the file, and I will just head from the whole file. It will just print the lines that have chromosome 1 CHR1B in that file. And so let me show you with another example. Yes, I have a file ncbi.tab. It is a good file to demonstrate grep. So let's see a part of the ncbi.tab. It actually contains some genomes. These are assembly accession numbers and the antibiotic resistant genes that are present in that genome. So there are around more than 2,700 genomes in these files, and the number of antibiotics that are present. So let's see WC of NCBI. So there are 20,740 lines. And if you want to just extract first and fifth column, that contains the name of the assembly and the name of the antibiotic gene, you can say cut field 1 and 5 and ncbi.tab and head it. So it will show just two columns. Assembly name and gene that is present. And if you only want to see BLA genes in the whole file, you can type that grep BLA ncbi.tab and it will print all the lines, only those lines that have BLA. So it's a huge file. And it has many genes with the pattern BLA. Okay. Yes, you can head it to see, just peek in to the file. So these are just the lines that have BLA. No other file, no other line is printed, right? Let's see what are some other. We have sort, we have unique. let's discuss sort and unique. These are the last commands I want to discuss today. Um, let's see how many antibiotic resistant genes are present in each of the genome. So there are more than 2,700 genomes, and in each genome there are multiple antibiotic resistant genes. If I want to see just the number in each of the genome, what I want to do is cut field one. So field one is basically name of the genomes and CBI name of the file, and I want to pipe it into unique. So it will just print the unique names, but I also want to know its number, not just unique names, but also its number actually, how many times it is repeated. So the first one file was header. It is only present one time, so it shows that this string is present one times. Second is this is a name of the assembly, and this assembly is present 10 times. It means there are 10 antibiotic resistant genes that are present in that file. Next assembly names, it is repeated 6 times. So six antibiotic resistant genes are present. This is how you can find that. And if you want to see which of the genome has maximum number of antibiotic resistant genes, just output the result of the first two commands into sort. That will sort the values, that will sort the values. Let's see what is output. So it is sorting from 1 to 3, and if you want to see maximum number of antibiotic resistant genes, you can use the in reverse order and then head. So maximum number of antibiotic resistant genes are 32, but I want to be more cautious. I want to sort numerically with an option N. Let's see. Yes, there are R means reverse the order, uh, show from highest to lowest, and N means sort it numerically. So 32 antibiotic resistant genes are present in that genome, 26 are present in that genome, 24 are present in that genome. So I think we should end this session and start a question answer session. We will complete it tomorrow. So uh, it was tough, right? If you are beginner, but the suggestion is there are many tutorials present in YouTube and on different platforms. You see, you watch whatever number of times. You cannot be efficient until you practice. Um, you may be very intelligent, but believe me, my experience is watching the videos of R, Python, or Unix, or Linux is of no benefit to you. Whatever you are watching or learning, just apply that by your own hand. This is how you can get efficient in this stuff. And try to do some project as well. So real-time project. Watch unlimited number of videos and tutorials, and you imagine that you know that after just 2 weeks, you watch again the same tutorial, and you will like, if I have seen that tutorial, this is my experience. So practice that thing. Any question, comment, concern on that? Let's take some questions from audience as well. So we have Akmal. Yes, Akmal. If you can hear that, listen me.
Assalamu alaikum, sir.
So I
Hello.
think we have today. Today I am connected to on my own system because that system was not set up with the Linux. So I think we cannot hear from the audience. We cannot take questions from audience. But Akmal, please, if you have questions, we can take it tomorrow from physically present people. If you people have any question.
Where we can apply this, can I apply this? Can I test it?
So, in the last class, I told that I install Windows subsystem. This is Windows subsystem. This is Windows system where I was training you people, and I have installed subsystem Linux, and I was practicing on that system. So you can also install Windows subsystem into your system, and you can do all the stuff. So there are two options of installing system. One that I told you yesterday, some of the people will be successful. If someone is unsuccessful, you may have to use PowerShell and enter into the PowerShell as an administrator, run as administrator. Don't open it just as a username, right? So you can practice this stuff into your own system. Yes.
By us, and double.
So single dot means current directory. Double dot means a parent directory. So single dot is a bit confusing. A good practice is to use a single dot. For example, I want to move from snips directory to a second directory. So I will say dot dot or dot / dot dot. It means the same. Good convention and good practice is to use dot. Dot means current directory, and from the current directory to dot dot parent directory, and from the parent directory to the second directory, right? So dot just means the current directory where you are in. If you say cd to the dot, it will remain in your current directory. It will not change. Yes, if you cd and type nothing, enter, it will go to your home directory. So if you are lost somewhere and you don't know where to go, so the solution is just to type cd, you will go into your home directory. Okay, okay, okay. Asterisk sign means anything, any number of times, and the question mark means anything, one number of times. Okay. So let's go back to ICCDS. If I want to print all the files that have an extension of txt, what should I do? I should do ls star, because I don't care what is before .txt. What I care is every file that have an extension .txt. It will print everything. So including file 10. But if I am interested in just file 10.txt and file 10.tab, what I should do? ls file question mark nt and everything. It will just print file 10 and file 10.txt and file 10 .tab. So what is happening? Question mark means one digit, and second question mark means another digit, anything. And then I pressed .t, and after t it can be anything. So it may be AB or it may be XT. So these are some differences between question mark and asterisk symbol.
The negative part is where we are. And so can we just simplify and simplify
Absolute path is from the root. So everything is on root. It can be a folder in a root and another folder in a root and another folder in a root, and you are in that folder. So your path from your root directory is absolute path. If you say print working directory, it will show your absolute path. So this is the absolute path. Relative path is relative to where you are in.
Can we see to my computer,
Uh, Windows have a different architecture.
just for,
Yes, you can see. Yes, you can say that because on your my computer there are 3 drives, C, D, and E, and everything is present in these drives. So nothing is outside my computer. So you can say that these are some equivalent, but they have different architecture. There is single. You can actually go to the root. Let me show you. You can go to the root, just CD and / with a space. You will enter into a root, but don't do that in your home. And ls, these are the files that are actually present in your root. These are system files, some libraries, some commands, uh, and there is mnt as well. Let's go to mnt. So from here, because I'm in root, I don't need to write / and mnt. I can just do mnt because I'm already in root and I'm using relative path. Mnt, I entered into mnt, and mnt has the CD and E different drives, right? Yes. Yes, I missed less. Let's go to the ICCBS less. Let's less NCBI. It will show. Let me clear first. Let's NCBI and press enter. It will show top, whatever we can print on a screen. And by using the down arrow symbol, you can go down wherever you want to go. So you can up with the up arrow, you can up the file, you go up the file. With down arrow, you can go down the file. And this is how you can scan the file, one page at a time.
the tab is actually file type,
Sorry?
dot tab, basically file type.
Dot tab. I haven't discussed anything dot tab.
Right, and dot.
Yes, tab is an extension. Dot tab is an extension. So when you are dealing with the files in bioinformatics, there are the fast Q files, there are fast A files, there are GTF files, there are TXT files, there are CSV files, and these extensions have meanings. For example, if you have an Excel file and you double click on that, Excel will open it. How Excel knows that it's an Excel file? By the extension. If you change the extension, Excel will not open that file. You can try that. So extension means something, and extensions are very important when you are dealing with data science or bioinformatics stuff. I have change the settings of my system so that it also show extensions, because sometimes you need to change the extension and Windows does not allow until you change the settings. You can go to File Explorer, view, and check this box, file name extensions. So show file name extensions. Right? Anything else? So I think everything is clear. I know that was a tough session but I will suggest that you people practice whatever we have performed. I will request that you people are shared with the slides, and if some of you have some problem in installing the subsystem, you can contact me. So thank you so much. See you tomorrow at 10 a.m.